Hi, welcome back to the channel. Today we're going to do a GCSE Mathematics High Tier Paper 1 non-calculator from 2018. This is an AQA paper, so we're just going to get straight into it with question 1. And it's an indices question, so it says simplify 5 to the power of 4 all squared. So here we're going to use the Indices Law. I'm just going to put the ruling on to the screen here. So I'm just going to use a as the constant, a to the power of m. If you put that all to the power of n, the way you work it out with any constant in place of a will be a to the power of m multiplied by n. So same as writing a to the power of m n. Mn is the same as writing m times n. So in this instance, we can substitute 5 for a, 4 for m, and 2 for n. So if we just write this out as 5 to the power of 4, and then because we've got the 2 outside, times by 2. So that is the same as writing 5 to the power of 8, which is this answer here. Question 2. Circle the volume in centimetre cubed of a cylinder with a radius of 5 and a height of 8. So the volume of a cylinder is the surface area of the front piece, and then multiply it through with the height. So we have here, so the formula for area of a circle is pi r squared. And then because this is a cylinder we're dealing with, we want the volume, so we just multiply it by the height, or if it was the length of it, then we could do it by the length. So in this case, we'll do it by height, so multiply by h. Now that's going to be, radius is 5, so 5 squared, and pi, 5 squared, times by height, which is 8. So 5 times 5 is 25, 25 times 8, and then pi, which is 200 pi. Because 25 times 8 is 200. So the answer here is 200 pi. Question 3. Simplify 16a squared divided by a plus 3a times 2. So we have a selection of answers here. So this is a case of using BODMAS, or some call it BIDMAS. So brackets, other, division, multiplication, addition, and subtraction. What that basically means is BODMAS tells you the order that these operations should be done. So you work out the brackets first, then other things such as squaring, then division or multiplication, groups of numbers before adding and subtracting them. So if we apply that same logic here, we can see that we have a squared involved, and then we next have division and we have a multiplication. So we've got a sort of division here, multiplication here. We've also got the addition in between. So what we'll do is we'll do it in the order of BODMAS, which is division, multiplication, addition, then subtraction. So what we'll do is we'll start by putting 16a squared divided by a, and that's basically 16a. So we have that piece here. And then we've got the second piece here, which we're dealing with. So we have 3a times 2, and we know that's 6a. So then using BODMAS, the next part is addition. So we have the two pieces here. What we can do is we can just now use that. So 16a plus 6a equals 22a. And your answer is 22. Question 4. Circle the value of cos 30. This is just something that you will need to memorize, and if you memorize correctly, you'll know that the answer is, and in fact in this one, √3/2. Question 5. Work out 8 1/2 divided by 2 2/3 give your answer as a mixed number. So what is a mixed number? A mixed number is basically the format that the question's been given out in. The alternative to a mixed number is an improper fraction. But in what you will have to do in this question is write it out as an improper fraction, do the division, and then once you get to the answer, then simplify it as a mixed number, as that's the easiest approach, because trying to multiply 8.5 divided by 2 2/3 and trying to do it as it is will be quite difficult. So one of the first things that we can do is we can change up each of these pieces. So what I'll do is I'll do the conversions and just talk you through it. So 8.5, how else can you write that? So if you want to write that as a improper fraction, the trick here is so you have the number that's outside of the fraction, so 8, you multiply it by the denominator, and then you just add whatever the numerator is. So in this case, you got 8 times 2, 16, plus 1, 17. So then that becomes your new numerator. The denominator always remains the same, so you just have that 17 over 2 as you had 2 here. So the next piece we're going to deal with is 2 and 2/3. Now, using the same concept as I mentioned above, we can write this out as 2 multiplied by 3 plus 2, as we have a 2 on the numerator side, and that is 2 times 3, 6, plus 2, 7, 8. And then obviously we leave that over 3. So now we have the two numbers as improper fractions. Now we can rewrite this division and then do the calculations. So we have 17 over 2 divided by 8 over 3. So we know that when you're doing a division of a fraction, what the trick is to multiply by the inverse of that fraction that you're trying to divide by. So in this instance, it will be 17 over 2 multiplied by 3 over 8, which makes this equation a lot easier, and then you can just work out simple multiplication on the top line or the numerator and the denominator. So this will be 17 times 3, and that will be 51, and then 8 times 2 is 16, so put 16 there. Cool. So now what we need to do is convert this back into the mixed number. So you need to figure out how many times 16 goes into 51. So it goes into it 3 times. 3 times 16 is 48. So you have 3 and then 48, and then to get that up to 51 you add 3, so then that'll be 3/16. So 3 and 3/16, that'll be your answer as a mixed number. Question 8. Kim works at an airport in the UK. She records the number of planes landing between 10 a.m. and 2 p.m. each day. The table shows the data for the first 10 days in January. So here is the table of the data. Part A, the airport was affected by fog on one of those days. Which of the days do you think it was? Please give a reason for your answer. So if we just look at the days and then the relating number of planes per day, if you just have a look at first glance, you look through 1 to 2, 3, 4, keep looking, and then you realise that by day 8 you begin to see a figure that's a lot less than the rest of the days. So the answer here I would put as 102, and that's day 8. Reason is it looks like it's an outlier firstly, and the second thing you could say about it is it's significantly lower than the other days. So Part B. Kim uses data to predict how many planes will land at the airport in a year. In her method, she uses an estimate of 150 planes in each 4-hour period throughout the day and assumes the number of planes each day. Work out her prediction. So 150 planes in each 4-hour period. So we want to work out the 24-hour period, and then we'll work out how many it is throughout the year. So 150 multiplied by 6, as this is the figure for 4 hours and we want the figure for 24 hours. This is 900. And then what we want to do is we want to do 900 multiplied by 365, which will give us how many planes will land at the airport as the prediction. But what I'll do here is I'll do 9 multiplied by 365. Once we get that answer, then we can multiply by 100. It's the same as multiplying by 900. It just keeps the calculations a bit easier. So 9 times 5 is 45. So I'll put the 4 here. 9 times 6 is 54 plus the 4. So it's 58. So we leave 8 here and bring the 5 forward. 9 times 3 is 27. Plus the 5, 28, 32. And then multiply by 100. So that's your answer of how many planes Kim predicts will land throughout the year. (8C). In fact, fewer planes land in winter than in the summer, and fewer planes land at the night than during the day. What does this tell you about Kim's prediction? Tick one box. So either her prediction is too low, too high, or it could be too low or too high. So either. The answer here is either. The reason for this is there could be more. If there's fewer landings in winter, then that means that Kim's prediction is too low. But fewer landings at night would make Kim's prediction too high. So that's the reason here that you would put. So fewer landings in winter. Thanks for watching. I hope you enjoyed it, and I'll hopefully see you on the next video.